Hello and welcome to Ms. Ma's Grade 11 Functions class. This is 8.2 Compound Interest. We're going to be talking about future value. So how much would your investment or maybe your loan be worth in the future if we were compounding? So of course we know the difference between simple and compound interest. Simple interest is just linear. So the formula was A equals P times 1 plus RT. And we could use that formula if we want. But if we're compounding, then we have to use this formula, A equals P times 1 plus I to the n. A, in this case, is the final amount for both of these. And P is the principal, that's the original amount that you would be investing or loaning. So let's just jump into some examples. Laura borrows $5,300 at 4.6 per annum, compounded annually. That's what this /A means. It means per annum, so that's the annual interest rate, and that's how all interest rates are declared. How much will she have to pay back if she borrows the money for 10 years? So here we have that n is equal to 10. That's the number of compounding periods. Let me just write that in there, compounding periods. And I is going to equal 0.046. That's the interest rate. And that would be the rate per compounding period. So it's not the annual rate necessarily. In this case it is because we are compounding annually. And we'll talk about what that means in a little bit. So we have n equals 10, I equals 0.046, and the P is equal to 5,300. That's how much she's borrowing. So we want to know how much this is worth in 10 years. We'll do A equals P times 1 plus I to the n, and we always want to write the formula, of course, as usual. And we just fill that in, 5,300, 1 plus 0.046 to the 10. You type that into your calculator, and you should get $8,319.84. That is how much Laura will owe in the end. So Laura will pay back $8,319.84 because it's a word problem. We're writing a word solution, and that's it. So here we have example B. Derek's grandparents investing $5,000 at 4.8% per annum, compounded quarterly when he was born. So we want to know what that means. Oh, I actually haven't written it into the chart. So basically we could have a term that is compounded at different times of the year. If we're compounding annually, we're doing it once per year. So if R is our annual rate, then we're going to have R divided by 1, which is really just R. And that's going to be our I. Okay, and the N is going to be, if our T is time in years, then our n will just be RT, right? It's just however many years we have. If we're compounding semi-annually, semi means we're going to do it times 2. So that means every half a year we're doing it. So times per year, that's going to happen twice a year. And that means that when we're doing our I, we do have to divide by 2. So it's actually R over 2. And the number of compounding periods is 2 times the number of years, right? So it's 2t. So for example, if I was compounding at 1.8% per annum, compounded semi-annually for let's say 3 years, we know that that's going to be, well, for every compounding period, let's say it does it in January and then it does it in July, right? So for this compounding period from January to July, I would want to have half of the per annum interest rate, right? Because it's going to have to add up to 1.8%. That's why we divide by 2 to get the I. So it would be 0.09% for this section, and then 0.09% for this section until December, right? And so if we're doing it for 3 years, we would have 6n, right, as 6 compounding periods. So it's January to July, July to December, and then again January to July, July to December again, and then one more time. So that's why it's 6, right? 3 times 2 is 6. So that is how we are getting those numbers, and that applies for all of these things in the chart. So if we're going monthly, then that happens 12 times a year, so it's going to be R over 12, and we'll have 12 times the number of years as their compounding period. Weekly, that there are 52 weeks in the year. If you didn't know that, now you do, and it's important that you know. So R over 52, and 52 times t. Okay, if we're going daily, there are 365 days in a year. They're actually 365.25, but we're just not going to account for leap years at all. So don't worry about the leap year, just do 365. So the I is going to be R over 365, and there are 365 times t days in a year, or in t years. And then bi-weekly, what this means is, you can also see, semi is times 2 and bi-weekly is times 2. This is every other week, so every other week. So that means we're going to take the number of weeks in the year and we're going to divide by 2. So bi-weekly, there are 26 compounding periods per year. So we would divide the interest rate by 26 to get the I, and we would go 26t to get the number of compounding periods. But the one that we want today for Derek's grandparents is quarterly. Quarterly means it's 4 times per year, as you could probably guess. So 4 times per year, we're doing R over 4, and then we'll do 4t, okay? So looking at this one, we've got $5,000 at 4.8% per annum compounded quarterly when he was born. So for part A, we want to do P is equal to 5,000. I is equal to 0.048, the per annum rate, divided by 4, which is 0.012. And I usually just put this into the calculator, and I'll put that into the formula as well, but if it's easy to divide, then you can just do it. And our N is going to be, it says after his 21st birthday, so 21 years. And if you think about it, it makes sense, because you might think it might be 22 years, but because it's like, what about his year 0? But when he's born, it's 0. When on his first birthday, that's 1 year. On his second birthday, 2 years. On his third birthday, 3 years. So N must be 21 times the number of compounding periods per year, which is 4. So 84. And again, I could just type that into my calculator. So A is equal to P times 1 plus 0.12 to the 84. Oops, I should have written what P is. It's a little early in the morning. So 5,000 right there. So you just type that into your calculator, away you go, and I get $36,657.80. So his grandparents made a wise investment. If we wanted to know how much interest they gain, so one of the questions was how much interest did they earn? The formula is the same as with simple interest, so it's going to be A equals P plus I. So in this case, we're actually going to flip it around and do I equals A minus P, and you can just type into your calculator, so it's $36,657.80. I haven't actually done this beforehand, so I'm just going to type it in, minus the original investment, 5,000, which ends up being $31,657.80. Okay, so that's how much interest they earned. And so for part B, how much will it be worth if on his 18th birthday he closes the account and puts the money into an account that pays 3.6 per annum compounded daily until he is 21? So this actually could be a pretty good idea, because compounding daily means that we could get a little bit extra money on it. If we are compounding more frequently, then we will earn more money. So that is a good thing, but 3.6% per annum is a lot lower than 4.8% per annum, so we'll try it out and we'll see. So basically, after his 18 years, I'm just going to change colors right here. Okay, after 18 years, we want to know how much money he's going to have. So A will equal 5,000 times 1 plus 0.048 divided by 4 to the 18 times 4. You just type into your calculator, and you could get an answer. However, I know that after 21 years, I'm going to take this original amount, let's actually call that A1, and I'm going to be compounding even longer. So after 21 years, it's going to be this amount, A1, times 1 plus 0.036, was it 3.6%? 3.6% per annum. So 0.036 divided by 365, and you can see why I don't want to do it in advance. I'm going to get a really small number, and I don't want to estimate it. So, so this is going to be 365 times 3 years, because 18 to 21 is 3 years. So what I'm really doing is A1, which is 5,000, times 1 plus 0.048 divided by 4 to the 18 times 4, times 1 plus 0.036 over 365 to the 365 times 3, right? Because I'm just replacing this A1 with the formula that I had found before. So you type that into your calculator, or of course you could estimate this and then type it and then put it in here and then multiply it by this to get your answer. But anyways, you should get approximately $30,723.33. So not quite as good as the first investment, right? So not a good choice. Okay. So that's that. Let's do one more example, I believe. Oh, actually, I think I have 2 more examples. So we're just going to compare if we were compounding monthly with compounding bi-weekly. So bi-weekly is more frequently, but let's see what the variable is. So it's when Ricky turns 45 versus when Uma turns 15. So the time will be a little bit different. So we're going to see if compounding bi-weekly will make a big enough difference. As we saw in the last one, it probably won't make a big enough difference, so we'll try it. So Uma, so we're compounding monthly, so it's from her 15th birthday to her 65th birthday, so that tells us the years is going to be 65 minus 15, which is 50. So let's just write that into our formula. A equals P times 1 plus I to the n. So A is equal to 10,000 times 1 plus 0.08 divided by 12 to the 50 times 12. You type that into your calculator and you should get 538,781.83. That's what I get on my calculator. And if we do Ricky's investment, he's only going from 45 to 65, so his years are 65 minus 45, which is 20. So his A equals P times 1 plus I to the n. He's going to have A equals P was 10,000 times 1 plus 0.08 compounded bi-weekly. Bi-weekly, there's 26 of those in a year, to the 20 times 26. $49,408.80. That's a lot less. So that time period really makes a big difference. It's a difference of 30 years. So this is a good lesson if you want to invest for your retirement. I know you're young, but it's better when you're young to invest because you'll have a lot more with a much smaller principal than if you invest when you're older. So it's good to remember. How much more will Uma's investment be worth? Just go back and read your question. Actually, I should have written it out. Shouldn't I have? Minus 49,408.8 is equal to 489,373.03. So Uma's investment is worth $489,373.03 more. Period. Now, Tharani wants to double her investment in 5 years when she graduates from a post-secondary institution. What interest rate will she need compounded semi-annually? So, this does actually not tell us what the principal is, but we actually don't need to know. We only need to know that she wants to compound semi-annually and that it's 5 years, and then we could just do it. So actually the A will be equal to 2p, right? Because whatever the original investment is, we want to double it. So A is equal to 2p, which is p times 1 plus I to the n. So 2p is equal to p times 1 plus I to the 5 times 2. So we're going to get 2 equals 1 plus I to the 10, because we could just divide out the p's. And in order to get rid of this 10 to the 10, we're going to 10th root both sides. So this will be 2 to the 1 over 10 is equal to 1 plus I. You type it into your calculator, and you get a pretty small number, 0.072, so 1.072 is equal to 1 plus I. Subtract off the 1s, 0.072 is equal to I. Now this is not the rate, the annual rate. We do want to know what it is annually. This is semi-annually, because that is how frequently she was compounding. So the actual rate is 0.072 times 2, which is 14.4-ish% per annum. That is quite the rate. So the Rani needs a rate of 14.4% per annum. Okay, so she's probably going to have to do some sort of aggressive investing in order to do that and not just put in the bank. So assuming she can get that interest rate and decides to buy a car in her second year of post-secondary, how much money will she need to invest? So we want to know if she wants to get $20,000 out of it or something like that. I've been looking at cars and I know a cheap car is about $20,000. So we want her A to be 20,000. So we're going to plug that into the formula now that we have an interest rate. So A is equal to P times 1 plus I to the n. So 20,000 is equal to principal, which is what we're trying to find, times 1.072 to the 4. It's 2 times 2. So in order to do this, we just divide 20,000 divided by 1.072 to the 4. So P is equal to 20,000. We're just dividing both sides. 1.072 to the 4. And you type that into your calculator, and you get 9,978.89. So that's how much she needs to invest. To buy a $20,000 car, she needs to invest $9,978.89. There you go. Okay, and one last part. Again, assuming she can get the interest rate in Part A, how long will she need to invest to triple her original investment? So we're just going to do A is equal to 3p, and we know A is equal to p times 1 plus I to the n. So I'm just writing out the formula as usual. So 3p is equal to p times 1.072 to the n. We don't know what n is, but this is number of compounding periods, just a reminder. So 3 is equal to 1.072 to the n. And now to solve this, you can either use guess and check or you can use logs. I'll just show you how to do logs just to remind you. We're going to switch the n and the 3 and put the 1.072 still in the base. So of 3 is equal to n, like this. And if you want to type into your calculator, you don't have a special calculator that can do that. You can just do log 3 over log 1.072. Or, of course, you can guess and check. So if you don't want to use logs, don't feel like you have to. So n is equal to 15.8. Now, this is not the number of years, so we're not done. This is actually going to be the number of compounding periods, right? And we know that we actually have 2t is equal to n, right? So we actually do need to divide n. So t is equal to n over 2. N is 15.8. Ish. I actually think I used the exact value and typed it into my calculator. But anyways, we get the time is equal to 7.9 years. If we want to be more precise, we can do 0.9 times 12, which is the number of months. So we actually can do 0.9 times 12. That gives us months. It actually gives us, I think it was 10.8 months. And if you want to find the number of days and be even more precise, we'll do 0.8 times 365. And it gives me 24 days. So it's 7.9 years, or 7.9 years, sorry, 7 years. 7 years, 10 months, and 24 days, if we want to be super precise. So that is the amount of time she needs to invest it. It's not bad, but that is a really high interest rate. Okay, so just to summarize, basically we can take this formula, a equals p times 1 plus I to the n, and use it in a variety of different ways to find any of the values. We could find a, we could find p, we could find I, and we could find n. And in fact, even if we want to find a and we're not sure what p is, if we're talking about doubling or halving or tripling or something like that, we don't need to know what the original investment was. We can just put 2 times p and solve it that way. So that is it. I hope you enjoyed it. Thanks for watching, and I'll see you soon. Bye!